Hello everyone, this is Chapter 3, Section 2, Geometry, and our essential question today. When two parallel lines are cut by a transversal, which of the resulting pairs of angles are congruent? Well, I don't know what any of that means, so maybe we should figure out what this means. So we've got two parallel lines that don't touch if you forgot. And we have a third line that cuts them. This is called our transversal. Now, trans means to move through, like transport, transversal. So, what it ends up doing is creating 8 different angles for us. What we're going to look at today is how these different angles have properties that let us know their measurements. So here are those properties or theorems. First one is corresponding angles theorem. This one says if two lines are cut by a transversal, then the pair of corresponding angles are congruent. What we really mean is angles in the same spot are congruent. So if we look, one is up here in the upper left. 5 is also in the upper left, so angle 1 is congruent to angle 5. 2 is upper right, 6 is upper right, so 2 and 6. Lower left, so 3 and 7. Lower right, so 4 and 8. So that's corresponding angles. The next one we have is alternate interior angles. The alternate means that they're on opposite sides of our transversal. Interior means they are inside our parallel lines. So let's look at where that is. So inside would be right here. T for transversal, so 3 and 6, 4 and 5. Similar to that is the alternate exterior. So the alternate means opposite of the transversal. Your exterior means outside our parallel lines. And like we said, the alternate means they're on opposite sides of the transversal. All right, so here's outside. Here's our transversal. So we're looking at 1 and 8, and 2 and 7. And the last one we have is our consecutive interior. Consecutive interior. This is also known as same side inside. So it's your angles that are inside of the parallel lines and on the same side. So 3 and 5, 4 and 6. Now be careful though, all the other ones were congruent. This one just adds to 180. Okay, so those are our theorems that we're going to use today to find some angles. All right, so it says the measure of 3 of the number of angles are 120. Identify these angles. Now, the other ones you can't forget about are vertical and linear. Remember, linear creates a line, you can draw a half circle. Vertical, you draw 2 lines, and it's the ones that are across from each other. Well, look at that. But 4 is across from 120. So angle 4 is 120 by vertical angle. Okay. Well, I noticed that these two are both upper left, so that means angle 5 is also 120 by corresponding, because they're in the same spot. And then finally, I see that this and this are alternate on opposite sides, exterior. So that means that 8 is also 120 by alternate exterior angles theorem. Okay, so I went kind of quickly through that, so make sure you rewatch the video if you missed anything. Okay, here we go. Let's look at this one. I need to find x. Okay, well, what do we know? Oh, these two are vertical angles because I can draw two lines and they're across from each other. So that means angle 4 is 115 degrees, and that's by vertical angle. But now if those are vertical angle, then I have same side, inside. Same side, inside adds to 180. We know this is 115 by vertical, so I get the equation. 115 plus x plus 5 equals 180. DC combine. Don't forget to solve equations DCM SADMAP. You'll hear me say that all the time. Minus 120, minus 120, x is 60. And that's all they wanted us to find was x. So we are done. So what you're kind of doing is it's like a puzzle. You're figuring out, okay, I don't know this and this, but I do know this and this, and that helps me get this and this. So let's look at maybe two more. Once you figure out the patterns, this really isn't too difficult. Okay. Well, what do I know? Oh, I know this is a linear pair. So that means angle 1 plus 136 equals 180, because those are a linear pair. So minus 136, angle 1 is 44. But if this is 44, well, what do we know about this angle and this angle? They're on opposite sides of the transversal, and they're both outside. That's alternate exterior. Alternate exteriors are equal, so 44 equals 7x plus 9 because of alternate exterior angles theorem. And now this is just an algebra 1 problem. Minus 9, 35 equals 7x, divide by 7, 5 equals x. And that's all they wanted. They just wanted us to find x. Now, while you're kind of writing that and processing this, I know it's going pretty quick, but just try your best. Once you see the patterns, once you see how these relationships work, it's just automatic. You look at it and you know exactly what to do. I once had a student say, Mr. Hunter, geometry is just kind of like taking a picture and turning it into an algebra 1 problem. And I think that's probably one of the most accurate descriptions of geometry. So let's just look at one more, then we'll call it a day. Okay, let's look at 2. To me, 2 is a little more interesting. So we have this picture. 1, 2, 3, 4, 5, 6, 7, 8. It tells us that this is 68. It tells us this is 2x plus 4, and it says, what does x equal? Okay. Well, I've got to figure out some way to create a relationship to get over to 8. I can't do alternate exterior because these two are on the same side. But I do know 1 and 8 are alternate exterior. So that means angle 1 equals 2x plus 4. So if I can figure out what 1 is, then I have an equation I can solve. Luckily, this is a linear pair. So angle 3, which is 68, plus angle 1 equals 180 by linear pair. Minus 68, we get angle 1 equals 112. So now I know 112 equals 2x plus 4. Minus 4 minus 4, 108 equals 2x. Divide by 2. And just so we don't forget, we knew 1 and 8 were equal by alternate exterior angles. All right, so that's the properties of angles. If you practice them, I promise you'll just start seeing the relationships right away. But you've got to practice it, and you've got to be good at this, so when we start solving triangles, you can see them quickly. So, until I see you next time, have a good one.